In this video, we're going to do the following problem. Add. Simplify by collecting like radical terms if possible, assuming that all expressions under radicals represent non-negative values. We have the square root of 490y minus 490 plus the square root of 10y minus 10. So we notice that the structure of those are quite similar and that each of those radicals contains a binomial with a common factor. So we can rewrite those expressions by factoring out that common factor. So we can say 490 times y minus 1 plus the square root of 10 times y minus 1. Next, what we'll want to do is identify any perfect square factors, if there are any, under each of these radicals. The factors in the second radical are 10 and y minus 1. And the factors of 10 are 2 and 5, so there's no perfect square factors there. And y minus 1 can't be factored either, so there's no perfect square factors there. In the first radical, we have 490 and y minus 1. 490 is divisible by 49, which is a perfect square. So we can rewrite this as 49 times 10 times y minus 1 plus the square root of 10 times y minus 1. So it's looking promising that we might have a like radical here. We can then break this up into two square roots, the square root of 49 and the square root of 10 times y minus 1 plus the square root of 10 times y minus 1, and the square root of 49 is 7. So we end up with 7 times the square root of 10 times y minus 1 plus the square root of 10 times y minus 1. Now, the expression that we're left with does contain like radicals. This and this are like radicals. They have the same index and they have the same radicand. So we can combine those together much in the same way that we would combine like terms by adding together their coefficients. So we need to envision that there's an invisible 1 here that's being multiplied by the second radical. And so we have 7 times the square root of 10 times y minus 1 plus 1 times the square root of 10 times y minus 1, which gives us 8 times the square root of 10 times y minus 1. And that's our final answer. I hope you found this helpful.